Some factoring problems. So what type of factoring do we have for the first one? Say it again. Yeah, GCF. And what is the GCF? 2x. Okay, 4x is left over, minus 11 is left over. Okay.
And then for the next one, you're going to get 5x squared.
Okay, so a GCF of 5, and then when you take out the 5, you have x squared minus 36. Yeah, and then after that I made it so it was difference of squares, and so we can keep factoring. Mm-hmm. Okay. Now the next one is what type of factoring?
The x thingy.
The x thingy, okay. So we're multiplying to 56. Okay. And it doesn't matter which order you put them, either order is okay. So you could do x plus 7x plus 8 or x plus 8x plus 7. Both of them are good. Okay. And then when we go to Desmos, which we're going to need for the last couple questions, we've got 3 and then SQRT for square root x minus 5, get out of that, minus 2. So there's our square root graph, there's our locator point. So the range is from down to up. So what's the bottom of the graph? What number is at the bottom? -2, we're going to use the y-coordinate, so -2 is at the bottom. And then the top goes forever, right? So what number do we use for the top? We use infinity. So the bottom is -2, the top is infinity. So we use the y-coordinate, top is infinity. So we're going to say -2 to infinity. Infinity always gets a parenthesis. What does -2 get? A bracket. That was an actual point that I was able to click on. Okay? If we look at the picture, it says, what is the increasing interval? So remember, for increasing and decreasing intervals, we always use x or y coordinates. Which one? For increasing and decreasing, x or y coordinates? X coordinates. The only thing that uses y coordinates is the range. Everything else is x coordinates. So the increasing interval is the x coordinates. What is the x coordinate right here? 5. And what is the x coordinate over here? Infinity, going right forever. Okay. So the increasing interval is what? 5 infinity. Infinity always gets a parenthesis. And then what does the 5 get? Bracket. Bracket or parenthesis, both are good this time. Some people do parentheses always for increasing and decreasing, and some people would say, well, right there he would be increasing. That's part, the whole thing is uphill, so it's part of the uphill. And some people put a bracket in there, and both of those are right. Okay. All right. G of -6. When I did this, I got the same answer as yesterday. Did I use that number yesterday? I thought I switched it. Maybe, I don't know. Okay, so if we plug in -6, at least I think I got the same answer as yesterday. You guys can tell me if I'm misremembering. So if we plug in -6, what answer do we get? -12. Isn't that what we got yesterday? I thought?
I think I turned the paper in.
Okay.
So
I have the papers from yesterday.
So with the number that's right there, you is supposed to put it on the front and back.
Yeah, wherever the x's are, that's where you plug it in. -38 was yesterday. No, that was the day before. What was yesterday? Maybe it was -38. Okay. And then we're taking k and we're plugging in 7z. So negative 7z 7z squared, and then plus 7z, oops, 7z, okay. And then what do I do? Has to do with the squared. Times it by itself, exactly right. So I've got negative 7z times itself, since that's what squared means. The other 7z doesn't really need those parentheses. And what happens if I do 7z times 7z? You're close. 49. Wait, 49. Z squared. Okay. I still have the negative in the front. Okay. 49z squared plus 7z. Oops. 7z. Can I add these together? No. Okay, that one's done. All right, and then h of k plus 1, so we're going to take the h function, we're going to take the x out and replace it with k plus 1. So negative 3, take the x out, replace the x with k plus 1, and then what should I do? Distribute the negative 3. So what do I get? Minus 3, and then I keep the negative 4. And so what is my answer? Negative 3k minus 7. Perfect. Okay. And then over here, what are they asking me to do? Wait, are we multiplying today? We're not multiplying. What are they asking us to do today? They're asking us to subtract the functions today. So f of x minus h of x. So f of x is 2x plus 1. H of x is negative 3x minus 4. We multiplied them yesterday. We can't multiply them 2 days in a row. It was the exact same functions, too. I wouldn't make you do the exact same problem 2 days in a row. Okay, so if we're subtracting them, what do we do?
You gotta change that to like just 2x plus 1 minus negative.
So we're taking the negative. What are we doing with the negative? We're distributing it. So what happens when you distribute the negative? Yeah, the negative makes plus. Yeah. So plus 3x, and then negative again makes plus 4. So plus 3x plus 4. $5x, and then, so 2x and 3x makes 5x, and then 5. Let's finish the warm-up and then you can go. Okay. So 5x plus 5. Okay. And then today I added a piecewise function because you guys love those so much I couldn't just let them go. You know what I'm saying? Okay, so how do we plug the piecewise function in on Desmos? Okay, we gotta type it in and we gotta get a squiggly bracket in there. Okay, so I've got 2x plus 4 to the second minus 3. Okay, there's that. And then I got squiggly bracket. X less than negative 2. Okay. And now what do I do? Okay, get the table. They're all undefined. What do I do? I need to make more. Do I need them over here or over here? I need negatives. I can see that from my graph, right? I need negatives. And I can see that from the equation itself, because the equation itself said left, that's a left arrow, left of -2. So I'm going to the left of -2 for my numbers. Okay, so -2, I'm going to press enter a bunch of times, and then I'll type in my numbers. So -2, -3, -4. So my numbers are starting to pop up. Well, I'm not going to be able to graph the rest of these. Yeah, those are too big. Okay, so this one right here, there was one day we were able to see it, but I don't know what the difference is. Nope. Okay, so -2, and what is that? There we go. -2, +5. We're going to graph that point. Should we fill in the point or not fill it in? Should not fill it in. Okay, so I'm going to graph the point -2, 5. So -2, 5. Sorry, the printer that I like to use, that I normally use, is out of ink. So I had to use the printer that I don't like today to make your copies. And I don't like it because it does terrible on graphs. So apologies. Okay, then we've got these points. So -3, -1, -4, -3. -5, -1. We got this one up here. -6, +5. Okay, so we got all those points, so we can go ahead and graph this. It looks kind of like that. Okay, did you guys graph that? Your paper look like that? Okay. And then I'm going to leave that there because I'm not done with that yet. And then I also have to graph -3, squiggly bracket. Oops, squiggly bracket. If x is greater than or equal to -2. Okay. And then we can get all these points in here. Let's get the graph to show up. There we go. So I'll do the same thing. -2, -3, -4. Okay, so we see some undefines, and then we can see all our points. So I've got -2, -3, -1, -3. -0, -3, 1, -3, 2, -3, 3, -3. So there's all my points. And this point right here, at -2 exactly, should that be filled in or not filled in? Filled in. Should be filled in. You can tell on Desmos, because right here at the very end, it actually has a point there. See this one? They didn't put a point there. They wouldn't put it there. Here they would. So it's filled in. Okay, so there's our graph. And then how do we find these values over here? On the charts, okay? So I look for -5. And let's see. -4, -5. -5 says undefined, so over, I'm going to write undefined. Is that what I do? No. If one says undefined, then what do? I look at the other table. So the other table for -5 says -1. Okay? And then this one for -3 also says -1. And then this one for -2 says undefined. So what should I do? Go to the other table. Okay, the other table for -2 says -3. And then for 0 it says -3. And then 4 isn't on the table, so I'm just going to type it in. 4, it also says -3. And then for 11, it also says -3. Okay, so this is what it should look like. All right, we good? We good on the warm-up? Everybody got it? Everyone participated? We all paid attention? We all wrote things down? All right. Get your name on it, get it turned in. Yes.
So when you do these, you don't put the parentheses in, it's just brackets.
So you put parentheses in for the equation itself. Notice how I put, like for number 1, I put parentheses in because my equation had parentheses. But then when I do the part where I say what the x value is supposed to be, x is less than -2, that gets a squiggly bracket.
Yeah, because from back here, it looked like you threw a parentheses.
Yeah. Nah, squiggly bracket. Yeah. And then we're also going to look at cubic equations because they work basically the same. So from yesterday, do you guys remember the very first step that you would do? If you wanted to find an inverse, what was the very first thing we would do? Trade the x and the y. So that's the very first thing we're going to do today as well. So x equals 2, y minus 4 squared plus 7. Okay. And then as we were trying to get the y alone, because that's our next goal, then we would say, okay, well, the first thing I can do to get the y alone is I can take this 7 and I can subtract it over to the other side. So now I've got x minus 7 equals 2 times y minus 4 squared. Oh, yes. Did anyone else have the assignment from yesterday and it hasn't been turned in yet? Finding the inverses of the straight lines? I think some of us turned it in. Yeah, yeah, you're good. You're good. Perfect. Okay. Our next step, we're trying to get the y alone. Our next step is going to be to divide. So this is just like yesterday. Divide. So just like yesterday. So now we have x minus 7 over 2. And if this was a problem from yesterday, we would have been finished. That would have been the whole problem. And then we would say, okay, the notation is y inverse equals the answer. We'd be done. But today, the problems are a little bit more complicated. So we're not done yet. So the next thing to get the y alone is we want to get rid of an exponent of 2. How do you undo an exponent of 2? Square root it. So now we're going to square root the left side and square root the right side. And on the right side, the square root and the squared exponent, they cancel each other out. So on the left side, I've got a square root over this fraction. On the right side, I just have y minus 4. All right, and if I want to get the y alone, what should I do with the 4? I should add the 4 over. Now, the 4 can't be added to the inside of the square root because it happened afterwards. So the plus 4 has to just stick on the end of the problem. You're going to have that whole square root kind of mess there and then a plus 4 kind of trailing along after. So now we're done. Now the y is alone, so I'm going to say y equals, I'm going to have my big old square root stuff. So square root with that stuff underneath it. And then I have the plus 4 kind of hanging out on the end. Now, I'm basically done, but I did forget something. Anyone notice what I forgot? The inverse thing. Y inverse. So I just have to say, okay, I've done all this work, so the inverse is what I just found. So we're doing a little bit more work than we did yesterday, but it's the same thing that we did yesterday. Okay, let's try it again. So h is the same thing as y. This is just another way of saying y. All right, so the first step is to do what? Switch the x and the y. Okay. Okay. And then what do we do? Take the 5 and add it over to the other side. Okay. X plus 5 equals negative y minus 1 squared. Okay. Now, the last time we had a 2 in the front, we divided by the 2. This time we have a negative in the front. So what should we do? We're going to divide by a negative. That's okay. Divide by a negative, divide by a negative. You can put a negative 1 if that feels more comfortable. Yeah. And so over here, this cancels out the negatives, right? Y minus 1 squared. And then over here, what happens to both of these if we divide by a negative 1? Because most people would not just leave a fraction with a 1 on the bottom. Yeah, it's going to take the two things on top and it's going to change the signs. Right now we've got a positive x and a positive 5. So if you take a positive x and divide it by a negative 1, what do you get? Negative x. And if you take a positive 5 and divide it by a negative 1, what do you get? Negative 5. Okay. So most people wouldn't leave it as a fraction. Most people would do that. Now, if you left it as a fraction, I wouldn't mark you wrong. I would just say most people wouldn't do that. Okay. All right. Negative x minus 5. All right. Now we want to keep going. We want to get the y alone. So what should we do next? We want to undo the exponent, right? We want to get rid of the 2. So how do we do that? Square root. So it's squared, and we're going to square root. Okay, so the square root and the square, they cancel out. Negative x minus 5. And this equals y minus 1. How do we get the y alone? We're going to plus 1. And at this point, our y is alone. We've got y equals that square root, negative x minus 5. The plus 1 happened later, so it's outside the square root. Yeah, now this is almost the right answer, but it doesn't look right because the original problem didn't say y equals. It said h. So our final answer has to say h as well, and it has to say inverse. So we're going to say h inverse of x equals the square root of negative x minus 5, and then the plus 1. We just have to make sure that we have the correct notation in there. Yeah, it's just got a couple more steps because the equations are a little bit more complicated. Okay, g of x is the y coordinate, so I'm going to show that that's a y. Okay, what's our very first step? Trade the x and y. X equals y plus 5 squared minus 9. Okay. After we trade the x and the y, what do? We're going to take this 9 on the end. We're going to add it over to the other side. Well, most of the problems have had something in front of the parentheses to divide by. So this one had a 2 in front of the parentheses we divided by. This one had a negative in front of the parentheses we divided by. This one doesn't have anything in front of the parentheses. So we're not going to have to divide by anything this time. So we kind of get to skip that step. So we're not going to divide by anything. We're going to go straight to square rooting. Square root to get rid of that squared exponent. And then how do we get the y alone? Subtract the 5. So the y is all alone. And then we have the square root. And then we have the subtract 5. But that's not the final answer, because the original problem had a g. And what does our final answer have to have? The inverse. So we're going to say g inverse of x is the square root of x plus 9 minus 5. All right, this one's got a fraction in the front, so let's see how it's a little different. So m of x, that's really just the y coordinate. All right, first step. Trade the x and y. Okay. Get rid of the 6. Yeah, this is the confusing part, right? So normally, if there was a number in the front, we would divide by that number, but the number in the front is a fraction, and dividing by fractions is very uncomfortable. So not divide by 2, multiply by 2. So in the case when you have fractions, it's actually easier to multiply by the opposite number, by the reciprocal. Do you guys remember that word, reciprocal? So we're going to multiply by a negative 2. Multiplying by a negative 2 will cancel this out. So if I multiply by a negative 2 on the right side, I'm going to multiply by a negative 2 on the left side. And I just want to make sure that I multiply both of these numbers by a negative 2. So an x multiplied by negative 2 is negative 2x, and then a negative 6 multiplied by negative 2, positive 12. Okay, and then on the right side, we just have our parentheses squared, okay? And then what do we do? Square root. So our square root and our squared cancel. And we get our square root equals y plus 2. And then we get rid of the 2. How do we move the 2 over? We're going to subtract the 2 over to the other side. So at this point, the y is all alone. So I'm going to say y equals my square root minus 2. Square root minus 2. Is that my final answer? No. How should I write my final answer? Okay. Okay. M inverse, and then my square root, and then my minus 2. I'm going to make sure my square root doesn't go too far. Okay. Okay. So how do we feel about the quadratic ones? Pretty good? Pretty good? Okay, I want to show you the cubic ones so you guys can see how similar they are, because they're almost exactly the same. So how are the cubic equations different? There's only one difference. What do you guys notice? The exponent's 3 instead of 2. Okay, so let's try the problem. So the n of x, this is the y value, right? Okay, so our first step is to do what? Switch the x and y. Okay. Okay, what should we do after that? Not divide by 3. Subtract the 8 first, okay. He was testing, he just wanted to make sure we all knew. Okay. Then you divide by 3. Okay. Now here's the part that is different. So instead of getting rid of an exponent of 2, we're getting rid of an exponent of 3. How do we get rid of an exponent of 3? Yeah, anyone remember what it's called? How do we get rid of an exponent of 3? Cube root. Cube root. So square root gets rid of a squared exponent, an exponent of 2. This is cubed, so a cube root gets rid of cubed, okay? So we're going to cube root each side. So that's a square root sign, but it has a little 3 in front of it. So we're going to cube root each side. So just like the previous problems we did, just with the little 3. So we got cube root x minus 8 over 3 equals y minus 5. Okay, and then what should we do? Add that 5 over. So the y is all alone. We've got the cube root and then the positive 5. Now this isn't the final answer, because what is the final answer? N inverse, okay. Then we got our cube root, and then our plus 5. Okay. Done. So I'm guessing we probably don't need to do any more examples. Probably feel pretty comfortable. So if it's a square exponent, you're going to do a square root. If it's a cube exponent, you're going to do a cube root. Otherwise, the process is the same for both problems. Does that make sense? Yeah? Okay. So I'm going to hand out the assignment, and then this is what we're going to work on for the rest of the period.